And then we changed the 1 to a 6. Changed it to the right. Okay, so let me catch up with you a little bit here. So, we were given what equation? Position, velocity, or acceleration? We were given an acceleration function. We need to find velocity. What should you be taking? The integral or the antiderivative, same thing. So the first thing you should have written on your paper is v of t is the integral of acceleration. Then you should have done the antiderivative. So your t is now squared. Your 6 is now a 3. Minus 18. The integral of a constant is 18t. Then plus c. Then from there, remember, you have to go back and find that c, but they should have given you a clue somewhere in the question as to what they were doing. So if you read right here, it says, at time t is 1, the particle is traveling 6 meters per second to the right. What is the velocity at 1 then? Positive 6. Okay, then my position is what at that same time? 10. Now, if it had said to the left, which it originally did, what would be different? Your sign would be negative, okay? So in this case, we're going to put our 6 here. We're going to put our 1 here. So we're going to have 3 minus 18 plus c. What is 3 minus 18? So that's 6 equals negative 15 plus c. What's c? 21. So cross it out, 21 right there. So this is our velocity equation right here. Okay? All right, part B. We want to know when the particle is traveling to the right. We need to do a what? A line test or a sign chart, whatever you want to call it. So 0 equals 3t squared minus 18t plus 21. What can we take out? 3. Hopefully you tried to factor that if you haven't already. That's a 6, that's a 7. What can multiply to 7 and have a difference of, oh no, should it be minus? Oh yeah, okay, but do you see what the problem is with that? Yeah. That's okay, just pretend. Okay, so what's our only critical number? 7 and... But why wouldn't negative 1 count? Because it's a negative time. Okay, so if you're confused as to what the problem is, technically are these the same? Answer's no. Because if I have a negative 7 times 1, that would make this minus. But just pretend you didn't notice. Okay, just pretend. You didn't even notice anyway until I pointed it out to you. Okay, so 7 and negative 1, but we're not counting negative 1. Okay, line chart. Remember that for time questions, you should start at 0. You shouldn't go back to infinity. Okay, then we're going to plug in, let's say, 1 on this side. So what is 1 minus 7? Okay, what's 1 plus 1? Negative times a positive. Negative, then positive. Which means that my particle, if these are the signs of my velocity, what was my position doing? I was traveling to the left, then to the right. So, question B says, for what value is my particle traveling to the right? Which interval would it be? Correct. From 7 till infinity. Okay, then because v of t greater than 0. Okay, next question says, and actually let me label this up top, that would be what the position is doing. So when my velocity is negative, my position is decreasing. When my velocity is positive, my position is increasing. Okay, next question, when is the particle's velocity decreasing? Good, if velocity is decreasing, then velocity's slope would have to be negative. But what's velocity's slope called? Acceleration. So acceleration would have to be negative. Which means that we need to take a second derivative test. Now, question, do we actually have to find the second derivative? No, they gave it to you right here. Okay, so we're going to let 0 equal 6t minus 18. Okay, good. T minus 3 is what's left over, which means that 3 is my critical number. And notice that since I see speed in the next question, I'm just going to go ahead and line them up. Okay, 3 would fit right here. And then from there, plug in 0. What do you get in here? Negative times a positive 6 is negative positive. Okay, remember that when acceleration is negative, velocity is decreasing. When acceleration is positive, velocity would have been increasing. Because remember, that's the relationship. Acceleration is velocity's slope. Okay? So on what interval is the velocity decreasing from where to where? 0 to 3. Next question says, when is speed decreasing? What are we looking for there?
The acceleration and velocity have to be opposite.
Good. Opposite signs. Where does that happen? Only one interval. 3 to 7. Very good. So between 3 and 7, your velocity is negative, your acceleration is positive. So that would be your interval there. Because v of t and a of t have opposite signs. Okay, and then remember we've talked about don't say different signs, say opposite. Plus and minus are opposite. You want to start using that vocab. Okay, next question, we want position. Velocity is right here. We want position. What do we need to do? Antiderivative. Or integral is the same. So x of t equals the integral of velocity. And then we're going to do it. Okay, so what's the antiderivative of 3t squared? You're going to add 1 to the power, then divide by that new power. So add 1, it's t to the 3, then divide 3 with 3. 1t cubed. Next term, my t is to the 1, increase it, now it's a t squared. Divide that 2 with the 18, now it's a 9. Okay, 21, antiderivative of a constant is 21t, and then plus c. And then remember, we were given this little piece of information right here that's going to help us find c. So 10 is the answer when we plug in 1. Okay, 1 and 21 make 22. 22 minus 9, what do we get? On this side. Huh? 12? It should be, hold on, that'd be 22. Take away 9, it would be 13. And then what do we do from there?
Subtract.
Yep. So C is what? Negative 3. Very good. So here's my position equation right there. Okay? Then part F says, is my particle initially traveling towards or away from the origin? Remember, towards or away is still a sign check, but what are you checking the signs for?
The x and v.
Position and
Velocity.
velocity. Very good. So find, and initially is what time value? Time is 0. So we're going to find x of 0 and v of 0. Okay, and remember 0 is easy to plug in because most everything crosses out. X is here, so I'd have 0 minus 0 plus 0 minus 3. What would I get? Negative 3. Okay, then come up here, we're looking at this one. Okay, we'd have 0 plus 0 plus 21. Okay? If my position is negative, which side am I on the number line? Okay, we're... Yes, Beyonce would be proud. You're on the left, but then if your velocity is positive, which way are you going?
To the right.
You're traveling to the right. Wow. Okay, so are we going towards or away then? Towards. No, we're just going to circle it. Okay, towards. Make sense? All right, the next one has an E in it. It's going to be so fun. Talk about a party. Oh yeah, I've been waiting all day for that one. Okay, number 2. Particle moves along the x-axis so that at any time its acceleration is given by, boom, E in it. Okay, at time t equals 0, the velocity of the particle is 6, the position is 16 units to the left. Write your x of 0 and your v of 0. They just gave you both of those. At time 0, the velocity of the particle is 6. The position is 16?
Negative.
Yes. Why negative?
Left.
Okay, yes, to the left. That means that I'm on the left side, I'm on the negative side of the origin. Okay, find velocity. We have acceleration, we want velocity, we have to do the what? Okay, so go ahead and do that for me. And what is the antiderivative of e to the t?
E to the t plus c.
E to the t again plus c. Because remember, if the derivative of e to the x is e to the x, then the integral is just the same thing backwards. Okay, from there, use your initial condition. You should be using the one for velocity, this one. Find that constant. You should not get 6. So I'd have 6 is the answer. When I plug in 0, what is e to the 0 though? 1. So then I have 6 equals 1 plus c, which means that c is 5. So I'm going to rewrite over here. My velocity is e to the t plus 5. Okay, next question. I need to find the position. What are we doing now?
The integral v of t.
Okay, so do that. And then you have your position, initial condition to go back and find your c. What's the antiderivative of 5t plus c? Then you plug in your negative 16, e to the 0 plus c. That's really a 1. Take it away. What's your c? Good, negative 17. So that's our equation right there. X of t equals e to the t plus 5t minus 17. Okay, next two questions are asking about if we're moving towards or away and if we're speeding up or slowing down. Okay, both of those are a double sign check. What are we checking the signs for in C? Which two functions? Okay, position and velocity. What are we checking the signs on for D, for speed? Velocity and acceleration. Now, I want to point out something to you. Okay, you could, on part D, do a double line test. But that's a ton of extra work. What time did they care about speeding up or slowing down? Only a single moment when time is 1. So you could have to do a double line test, but they also could just give you a number, which is what they gave you here. So let's do C first. We're plugging in x of 1. What am I going to get when I plug in 1 here?
E to the 1 minus 12.
Okay, I'm going to just put plus 5 minus 17. Okay, but then think about, E is about what? 2, plus 5 is about 7, take away 17. Overall, it's going to be negative, less than 0. Does that mean that I'm on the left or the right? We're on the left, on the left. Which way are we traveling? We'll find out next. Okay, what is V of 1?
2.
Okay, you'd plug in your 1 here, you'd have E plus 5, right? Well, how does that come out? Positive. Which means which way are we traveling? Okay, we're traveling to the right, which means which way are we going? Towards, good. Okay, do the next two. And actually, V of 1 we already know. I'm just going to put greater than 0 because we already did it. So you just need to find A of 1. What will A of 1 be? E to the 1, which is greater than 0. If they're both positive, then we'd be speeding up. Now, I'm going to write something wrong. Because A of t, V of t have same sign. What is wrong with it?
A1,
Yes, this says that acceleration and velocity at any time have the same sign. Is that true?
No.
When are they the same? At once. So you have two choices. You can put at t equals 1, but I would put A of 1 and V of 1. And don't make it generic, make it specific. We're talking about a single time value, so we want to make sure that our explanation matches that as well. Okay? All right, turn the page. Sighs of joy. Okay, we need a calculator for this one, but we don't for number 4, so let's do that one first. Okay? Alright, number 4, we have a particle moves along the x-axis so that its velocity is given by 2 over t minus 1. The position of the particle at time t equals e is x of e is 5. Okay, part A, when is the particle at rest? What do we do to find when the particle is at rest?
Velocity 0.
Okay, velocity equal to 0. Okay, so look at our velocity function. We want to set this equal to 0, yeah? So, 2 over t minus 1 equal to 0. You cannot have one thing that's a fraction and one thing that's not and do a sign chart. So what do we have to get? Common denominator. Good. So I'm going to take my 1, and if this has a t on the bottom, I'm going to have to put a t on top and on bottom. Because remember, we have to bring that all into one big fraction, not separate fractions. Okay, so from there, what is our fraction going to be now? 2 minus t on top, t on bottom. Now remember, critical numbers can come from the top or the bottom. They can come from either spot. So what's my critical number on the top?
Negative, positive
Positive 2. What about on the bottom?
2. 0.
Why would I cross out 0 though? Normally 0 is allowed.
Because it's put 0. I don't know.
Greater than 0.
Yep, look right there. At time t greater than 0. Normally 0 would be allowed as a time value, but for this particular question they cut it off. They said it doesn't count. So for my line chart for part B, it asks when my particle is traveling to the left, 2 is going to be my only critical number. Okay, let's say that we pick 1 on the left side. What is 2 minus 1 on top? 2 minus 1 would be positive, then divide by 1. Positive. Okay, say you pick 3. What's 2 minus 3 on top? Negative. That means that my particle was traveling to the right, to the left. So when is my particle traveling to the left? Which interval? Because v of t less than 0. Okay, part C says write an expression for acceleration. Do we need to do the antiderivative? Yes, if you have velocity and you want acceleration, that's a derivative. Now, when are we going to do an antiderivative to get to what? Position. So you have to think about if you have velocity to do acceleration, we're going to need to do a derivative. Okay? So I'm going to give you the rewrite for it, and then I want you to take the derivative. So v of t, this is my rewrite, is going to be 2t to the negative 1. Okay, because remember, if that t is on the bottom, you don't want to have to do quotient rule. Okay, so take the derivative of that, and then I want you to answer question D. You guys want some candy to wake you up? Yes? No? You want the Super Bola. Say it. Okay, do those two. You can work with each other. I'll also give you a single grape instead for the healthy people.
Instead of single grape.
I brought some grapes for lunch and I haven't eaten them yet. So if you would like to have a grape. You want a grape though? I got you one grape. I'll bring you some. it's a pinata surprise too. You don't know what you're gonna get. Helen, you want one? Want one?
How do you do the
Helen, I'll bring you a grape, don't worry.
I forgot how to do the derivative.
Did you know that dogs can't eat grapes?
No, it's
Or they can die?
yeah, they kind of out and minus the
They're really bad for their tummies.
Babies can't do theirs.
Yeah, because there's something about like the skin that they're touching.
Did you get 2 tea for the first one, Helen?
Huh? I also have to
That is
I'm
There you go. Girl. I'll be awkward.
You can have 2 since you came back to us. Try to sneak and draw. You gotta go out. You can get one. AK, what happened to you?
Oh, I was talking to the
Hey, you're supposed to be taking the derivative, not just sitting there waiting for a grape.
He's smart.
Just for you, you're smart. Come on, take you a little grape. Yes. You can take 2 even. Okay, I'm feeling generous today. Take your life. Come on, take another one. Ray needs it. Okay, Helen, take a grape. Come on. Just one? Okay, you have 2.
Is it just one?
Each one has about 8. Okay, pure energy.
Wow.
No else wants one, James. You said you wanted a grape. Come on, they're good from Kroger. Kroger, great food.
Kroger has
Yes. All right. Did you want a grape? You want 2? You want one? You want a grape? I'm trying to bribe them to work with food. Yep. For real though, do you want one? Yeah, go for it. Sure.
Can I have a strawberry?
Might be rotted, but just kidding. They're not rotted. Okay, what was your derivative?
Over T squared.
-2 over t squared. Good.
Right.
Then in part D, you should have found v of 1 and a of 1. Okay, now v of 1, you have 2 over 1 minus 1. How does that come out? Positive or negative?
Positive.
Okay. A of 1, we're plugging in right here. How does that come out?
Negative.
It does come out because remember that -2 on top over 1 is going to make it negative. So, speeding up or slowing down?
Slowing down.
Good. Because your exponent is negative, so you multiply the -1 down with the 2, and that makes it a -2, and then you take away 1 more and it becomes squared. Okay, next one, we want position. Now, if you try to do this rewrite, look right here. If I want to do the power rule on that, what happens when I add 1? I get 0. And then what am I supposed to do with the exponent? You're supposed to divide. Can you divide by 0? No, that means it's special. What is it if t's on the bottom? What's the integral of 1 over t? ln t.
Can you repeat that? Oh,
Yep.
bracket.
Yep. Okay, remember that the integral of 1 over x is ln x. So any time that you have only one x on the bottom with a constant on top, your integral is going to have an ln in it. So for my rewrite here, I'm going to write that as 2 times 1 over t minus 1. And then if we want position, we're going to have to do the integral of that. So the 2 is going to stay in the front, and then what's the integral of 1 over x?
ln.
So it'd be ln of t. What's the integral of minus 1?
1t.
Minus 1t plus c. And then somewhere up there, they must have given you the position at a certain value.
5.
X of what?
E.
X of E is 5. So that means that 5 is the answer when we plug in E. What is the ln of E?
0.
Not 0, it crosses out to be
2.
1. So these, think about that's like an E to the 1. So when the ln and the E cross out, you have a 1 in that spot. So 1 times 2 is 2. 5 equals 2 minus E plus C. Okay, let's get C by itself. What do we do with the 2?
3
Minus it, so now it's a 3.
plus E.
And then if that's a minus E plus C, then I just need to add that E across, and C will be 3 plus E. And then I'm going to come back right up here. I'm going to cross out my C. I'm going to put 3 plus E instead. Now, what is missing from my page that I should have written? In part E. What should I have written before I wrote this? What is X? V of T. Okay? And it doesn't matter necessarily where you put it, but you want to make sure you put it somewhere because you're showing you know the relationship, that it was an integral. Okay, then part F says towards or away from the origin at E. What two things are we plugging into? Position and velocity. So I want to know X of E. I want to know V of E. Let's do X of E first. We're plugging in right here. That'd be 2 ln E minus E plus 3 plus E. What's going to cross out? The E's are going to cross out. And then you have 2 ln E plus 3. I have two positive things added together. How does it come out? Greater than 0. Okay, then for velocity, I'm going to use this version right here. We have 2 over E minus 1. Okay, think for a second. Don't say it out loud. Think about how this is going to come out. Remember, E is about 2.7-ish. What is the value of 2 divided by 2.7? Is it bigger or smaller than 1? Smaller than 1, and then I minus 1, how does it come out? Less than 0. One's positive, one's negative. Are we going towards or away? If you're not sure, where are we, left or right?
We're going away.
We're on the right. Which way are we moving? Moving left. So where are we going?
Away.
Oh, towards. Because think about, on the number line, you're on the right and you're moving left. Yeah? So towards. Okay. How much time do we have left?
10 minutes.
Okay. If you have questions on your homework, we will do this last question because I told y'all I'd answer them. So, what questions we have? Only homework 1 is due today. Homework 2 will be due next Friday.
Okay. 14.
Homework 2 is due next time.
14.
14.
Okay, I'm not doing it, okay? Is that a problem for you?
Okay? Alright, let's look at 14 first. We have about 10 minutes. Okay, now that first one should look familiar because we just did one like this just now. What is the 3 over x? What's going to happen? Yes. Yes. Yes, you would rewrite this as 3 times 1 over x. Why would we do that? What's the integral of 1 over x? ln x. Very good. Now, for the second one, it's going to be x to the minus 2. Y'all see that? So the 3 gets separated, 1 over x stays, because we have a special rule for that. But then on this one, we're pulling that x to the 2 up, we're turning it negative. So, antiderivative, what's the antiderivative of 3? 1 over x. ln. Technically, it does have an absolute value there, okay, which we'll practice more as we go through the year. Second term, add 1, what's the power? negative 1. Then I have to divide by negative 1 under my 3. So it's a minus 3. Okay, now could I rewrite this as 3 over x? Yes, you probably should. That's how they'd put it on the AP test. So that'd be 3 ln x minus 3 over x plus c. That would be like your perfect answer. What else? Do we want to do one of the double integrals from the back? Where you did it twice? Okay, which one? Tell us, Justin. Which one? 12? Okay. Number 12, you probably would have needed your pink sheet for that, but lucky for you, I have one.
Wait, well, I think we already did in class.
Oh, we did? Okay, well, cosecant cotan is right here. Yeah, you can have this one.
Number 7. Do we have to like
Distribute first.
and then take the
Yep.
antiderivative? Okay.
Yep.
Lots of nice.
What else? Come on, people. We did some of this in class, so. Want to do one off the back? See how you did?
Yeah.
Alright, let's do number 23. Okay, f double prime is sine. Integrate on both sides. What's the integral of f double prime called? F prime of x. What's the integral of sine? Snow cone, snow cone. Negative cosine x plus c. Very good. Which initial condition are we using? First or second?
The first.
Okay, so 1 is the answer when I plug in 0. Is the cosine of 0 going to cross out?
No.
No, that's a 1. So it's negative 1 plus c. Add your 1 across. What's c? 2. So I'm going to cross it out right there, put a 2. So f prime is negative cosine x plus 2. Okay, f is going to be the integral on both sides of that. Okay, what's the integral of f prime called? F, what's the integral of negative cosine? Think about your snow cone, snow cone. Negative sine, very good. And then it'd be negative sine plus, what's the antiderivative of 2? 2. Well, we're using x here, so let's, so it'd be negative sine x plus 2x plus c. And then from there, you'd use your f of 0 to check. So 6 is the answer. Plug in 0. C is 6. How'd you do? Great.
You're right. Don't want to be.
Dude, we did 21 in class, didn't we? Or no?
No. Yeah.
Circled it, we did.
Justin was like smoking crack back there. I think I have it from the other class, so I'll let you see it. Okay, well then finish up your homework. It's due today. If you don't finish it in class, okay, you can give it to me after school, but after today it'll be late, okay? Hold on, let me see. We did do this one. Let me see if I have it.
So what's the range?
Here you go. Because when you bring 1 over x and ln x plus c, then you plug in this thing and the ln x and then you cross it out.
I can give you some food.
What is the speed at that time? Did you find when his position is 0? Because remember, when he hits the water, his height is 0, because he's on the water. So you set that equal to 0, and then when you find that time, you go back to the
You
plug
put
in.
h 0 equals this again.
And then you factor out whatever they have in common.
Wait, I did that. It's 0.
What?
No, it's t5.
No, hold on. Then you did that. That is when velocity is
Bad handwriting, I know.
I don't think it's the handwriting.
Gotta use.
Yeah, flip
Okay.
it on stage.
Yes, when you did the max height, you should have set velocity equal to 0 and done a sign chart. Because think about it, your guy is like, well, actually, ironically, it still did plus minus, but that's not the same.
Okay, yeah.
So you need to do a first derivative test here. And so if you factor out a 32, what time value would be? And then 5 is when he hits the water. So he hits his max at 2, and then he hits the water at 5.
Okay.
Make sense?
Yeah. And I believe it's this one as well.
Okay, your acceleration is negative 32.
Oh,
Negative 32t plus c. Oh yeah, where's his velocity? His initial velocity was 24. Okay, yeah. Then you integrate it again. Right? Negative 16t plus 24t plus c. And then what was his height? 3 feet. So you should find your c. Because think about it, the only thing that's changing from Earth to Mars or whatever is the gravity.
So I find my C
And then you want to know what his max height is. So you would let your velocity function equal 0 and then find how tall he was at that point or how high the rock was at that point. Does that make sense?
So what word, can you take all?
I'm probably going to go ahead and just give you a 0 so that we can keep, where you tell me that you turned it in.
Yeah, she always
And then I tell you that I'm going to fix it and then I'm not going to fix it
So the
until you
last
bring it
video.
up like at least a few more times. Because that's really just been really fun for me. Helen, do you have yours?
For this
Oh, and you want it back, Helen?
this one, you plug in here, and then what do you do? This, oh, I know what to do.
Oh, Lord have mercy.
Cousin, where were you?
This section I had